subscribers or new video viewers. My name's Nikki and today's video is an introduction to concentration. Woo!
So today let's talk about concentration. We like to say that this solution is very concentrated, i.e. that there are many particles of solute per unit volume of the solution. So here are some related terms and words that we should know. How about solute, solvent? There's solution, dissolve, dissociate, ionic, covalent, etc. So let's use an example here and see if we can work out something about solution. Here we'll put 1 gram of sodium chloride in 3/4 of a liter of distilled water. And in the second container, we'll put 0.4 gram in just 0.2 liter of distilled water. The question, of course, is which is more concentrated? On the right-hand solution, we can make a ratio of mass of sodium chloride to volume here, and you find there's 2 gram per liter. On the left, the same, we find there are 1.3 gram per liter here on the left-hand side. Therefore, we'd say the right-hand side solution is more concentrated. There are more particles per liter of solution. But we said concentration was number of particles per volume and not mass per volume. So the conclusion is right, but we haven't really calculated the concentrations themselves. The concentrations will be proportional to these mass per volume calculations we've done up there. So let's introduce the idea then of molar concentration, which we are going to call molarity. So here's a definition for the word molarity, and we'll say that that's the number of moles of a solute particle per liter of the total solution. So here are a few ways to express that. We have mole per liter. Sometimes it's used with a large capital M, and we say that solution is molar. So these square brackets means concentration of. So let's give this second sodium chloride solution another look here. So there's 0.4 grams of sodium chloride. Now we're going to turn this into moles by using the molar mass. And now we'll divide by the total volume of that solution, which is 0.2 liter. So there's the moles, divide by the volume. Check all the units come out as moles sodium chloride per liter. They do. Per means divide. And we get 0.034 mole of sodium chloride per liter solution. Or you could write it like this. The sodium chloride aqueous solution concentration is 0.034 mole sodium chloride per liter. Or, in shorthand, you could write the concentration of sodium chloride solution is 0.034 molar with a capital M. Anyway, let's put this all to work and see what we can do with another solution. Here's 115 grams of aluminum nitrate, and we'll just dissolve that into enough distilled water, remember DH2O is distilled water, to make 2 liters of solution. So the first question we have would be, of course, what is the concentration of the aluminum nitrate solution? Well, we have 115 grams of aluminum nitrate. Let's work out the molar mass. I think it's 213 grams per mole, so we'll use that value here to turn this mass into moles, and then divide again by the volume of the solution, which is 2 liters. So I think if you do this, check the units, you get 0.270 mole of the aluminum nitrate per liter. And we can write our solution here. Concentration of aluminum nitrate is 0.270 mole per liter, capital M for molar. Let's get the concentration of dissociated ions in the solution. So remember that the aluminum nitrate will dissociate in solution, giving you 1 aluminum ion and 3 nitrate ions. So if you think about the mole ratio, which is 1 to 1 to 3, I think you'd quickly come to the conclusion that the aluminum ion is going to be the same concentration as aluminum nitrate. It's 0.270 molar, but the nitrate ion will be 3 times that amount. Remember, that'll be 0.81 molar. Why should it be 3 over 1? It's actually 3 nitrate ions for every 1 formula unit of aluminum nitrate that dissociates. So those are the concentrations of the ions. Okay, let's look at another situation here. Let's say we want to make 1.25 liters of a half molar aluminum nitrate solution. The question is, what mass of aluminum nitrate is required? How to do it? Well, let's start with our 1.25 liter of solution we know we need. In every 1 liter of that, we'll need 0.50 moles of aluminum nitrate. This is the same information in green here and above. And then we'll just make sure we get the molar mass of aluminum nitrate here in the next step to figure out the mass. So here we have the molar mass. 1 mole of this stuff we said was 213.0 grams. If you mind all the units, you will see they all work out nicely and you wind up with these 133 or 130 to 2 sig figs grams of aluminum nitrate that are required to make that solution. So the essential skills are 1. Determine the concentration, 2. Determine the number of moles or mass, and finally determine the volume. All these come very cleanly from unit analysis and the definition of molar concentration as mole solute per liter solution. So that's the whole story. Thanks everyone, and we'll see you soon. So have a look at the next 2 videos in this playlist for more on the topic of concentration, and stay tuned for our next lesson, dilution, evaporation, and mixing.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!
Hey all you subscribers or new viewers, it's Nikki, and today's video is an introduction.